Welcome to the Explainer. Today, we're putting on our detective hats to solve a geological mystery that took scientists more than 50 years to crack. This is a puzzle that totally changed how we see the very ground beneath our feet. So let's jump right in with our first clue. Okay, think about this for a second. Over here in North America, you've got the Appalachian Mountains. Then you cross the entire Atlantic Ocean, and in Scotland, you find the Caledonian Mountains. And here's the crazy part. Geologically, they're identical. We're talking the same rocks, the same age, the same structure. How on earth is that possible? It's like finding two halves of a torn-up photo thousands of miles apart. It just doesn't make sense. Or does it? To even start to wrap our heads around this, we've got to go way back to 1912 to a German scientist named Alfred Wegener. Now, he looked at clues just like this, these mountains, fossils of the exact same plants and animals showing up on different continents, and he came up with an idea that was, for the time, completely radical: continental drift. So Wegener's big idea was that the continents weren't fixed in place. He thought they were actually drifting around the globe. Now, at the time, the scientific community pretty much laughed him out of the room. I mean, he could see what was happening, but he had no way to explain how. He was missing the engine. Still, he had planted the seed of a revolutionary idea. So for decades, Wegener's idea was just kind of out there, on the fringe of science. To really crack this case, scientists needed some cold, hard evidence. And the first real breakthrough came from a tiny, microscopic time capsule, hidden deep inside the rocks of those very mountains. Let me introduce you to the zircon crystal. For a geological detective, this little guy is your best friend. I mean, these things are unbelievably tough. They can survive for billions of years. But their real magic trick is what they trap inside of them when they first form from hot magma. And here's how this incredible geological clock actually works. See, zircons trap the element uranium when they're born, and over millions and millions of years, that uranium steadily decays into lead at a perfectly constant known rate. So, by measuring the ratio, how much uranium is left compared to how much lead there is, scientists can calculate with amazing precision exactly when that rock was formed. It's literally like winding back time. So here's the kicker. When scientists dated the zircons from the Appalachians and the Caledonians, they got a perfect match. This was undeniable proof. These two mountain ranges were once part of a single gigantic range we now call the Central Pangaean Mountains. Wegener was onto something big. But the smoking gun, the final piece of evidence that would blow the case wide open, was still hiding, deep at the bottom of the ocean. After World War II, we started mapping the ocean floor in detail for the very first time. And what we found was just astounding. It wasn't some flat, boring, featureless plain. No way. The ocean floor held a secret code, a perfect recording of our planet's entire history. Honestly, the best way to picture this is to think of the ocean floor as a giant magnetic tape recorder. As brand new rock bubbles up from inside the Earth, it literally records the planet's magnetic field at that specific moment in time. It's just like a tape recorder capturing sound. And here is where it gets really wild. Earth's magnetic field isn't stable. Every few 100,000 years or so, it completely flips. North becomes south, and south becomes north. It's incredible. And every single one of these reversals gets captured, frozen in time, in the rocks forming on the ocean floor. So you're probably asking, how does this recording actually get made? Well, it all happens at these enormous volcanic seams that run down the center of our oceans, called mid-ocean ridges. Magma wells up, it cools into new rock, and as it does, it literally shoves the older rock out to either side, like a slow-motion conveyor belt. The result is this stunningly clear pattern. On either side of that ridge, scientists found a perfect, symmetrical mirror image of magnetic stripes, bands of rock showing normal and reversed polarity. There was only one possible explanation for this. The seafloor itself was spreading apart from the center. This was it. This was the engine. This was the how that Wegener had been missing all along. Okay, so let's put all the pieces together. We have the zircon dating, which proved that continents were once connected. And now we have seafloor spreading, the engine that could actually move them. Suddenly, all the clues just fell right into place. By the 1960s, the evidence was just overwhelming. Alfred Wegener's once ridiculed idea of continental drift was reborn as the powerful theory of plate tectonics. This theory explains that the Earth's outer shell is broken up into these giant plates that are always in motion, driven by the spreading of the seafloor. The case of the impossible mountains was officially closed. The mark of a really great scientific theory isn't just that it solves old mysteries. It gives you a powerful new tool to understand new ones. So let's put our theory to the test on another geological puzzle, the Hawaiian Islands. Now, this one is a bit of a curveball. See, Hawaii isn't sitting on a plate boundary where you'd normally expect to find volcanoes. It's this long chain of islands right smack in the middle of the massive Pacific Plate. So what in the world is going on here? Using our new theory, there are really two main suspects. Either the islands are forming at some kind of hidden plate boundary we can't see, or the plate itself is moving over a stationary source of intense heat deep inside the Earth, something we call a hotspot. So, which is it? What does the evidence tell us? Well, when we date the rocks from the islands, we find a crystal clear pattern. The big island of Hawaii, which is volcanically active right now, is the youngest. And as you travel along the island chain to the northwest, the islands get older and older and older. And that age progression perfectly matches the direction the Pacific Plate is moving. It's a perfect match. The verdict is in. The hotspot theory fits the evidence perfectly. The massive Pacific Plate is just sliding like a conveyor belt over this fixed plume of magma. And every time the plate shifts a little, a new volcano pops up, creating this beautiful trail of islands. Plate tectonics solves the case once again. And that really brings us to our final thought. This isn't just ancient history we're talking about. It's happening right now, literally right under our feet. The continents are still drifting. The oceans are still spreading. The very forces that split mountains and built entire islands are still at work today. Which leaves us with a pretty fascinating question to think about. What will the map of our world even look like 200 million years from now?